first theorem that we're going to prove with the Euclidean parallel axiom says that if two lines cut by a transversal are parallel, then any pair of alternate interior angles are congruent. And this is going to be theorem 1.001. Actually, let's change that. Let's make it 1.010, just in case I have to backtrack for some reason. Meant to name it differently throughout the whole thing and skip numbers every once in a while, but I've been doing a bad job of that. Proof. First thing we need to do is draw a picture to make this easier to understand. Let's draw it down here. It's a little bit longer proof than normal. So we'll have two lines, L sub 1 and L sub 2, cut by some kind of transversal. And we need to say that any pair of alternate interior angles are congruent. Let's get started. We'll say, given the parallel lines L sub 1 and L sub 2 cut by a transversal T, we'll say let angle 1 and angle 2 be alternate interior angles. So let's just name these. We'll name, we'll do this in orange. We'll name this one angle 1, and alternate interior angle to that one would be this one angle 2. We'll say using angle construction axiom, we construct line L sub 3 through Q forgot to name that. This is point Q. Oh, let's need to name this one down here also. We'll call this one point P. Anyways, line L sub 1 through L sub 2, or line L sub 3 through Q, such that angle 3 is congruent to angle 2. So let's see. We have some kind of line going through line L sub 3 going through Q. So we'll draw that there, and we'll say this angle right here is congruent to angle 2. Notice whenever we get weird drawings like this, we're normally going to some kind of proof by contradiction, which is what we're going through here. Well, kind of a proof by contradiction, it's a little bit different. And we'll say since angle 3 and angle 2 are alternate, interior angles, it follows from a previous theorem that L sub 3 is parallel to L sub 1. Well, we already assumed, actually we'll say we already have L sub 2 parallel to L sub 1. However, since L sub 3 and L sub 2 both intersect at point Q, it follows that, or actually we'll say it follows from the Euclidean parallel axiom that L sub 3 equals L sub 2. Also, because of that, angle 3 is congruent to angle 1. Therefore, angle 1 is congruent to angle 2.